Hi guys, you're welcome to my channel. I'll be looking at these three questions. I obtained all these questions from sybermath, and the method I'll be using is also from sybermath. Sybermath is our YouTuber and is very good in problem solving approach. I've been following his channel for like 2 months now. Now I saw this particular question in response to Michael Payne's video. I love the method in which he uses solving this question, and that's why I'll be using exact method to solve what exact question, and I'll be giving you a likely question that we are going to be using the same approach in solving what the question as well. Let's start. Question 1. Okay, I would like to put the question in the corner here. For the first question, 2x plus 1, then x plus 3, we are looking for the y prime. For the second question, integral of e to power of x, sine of x dx, and the third one, the integral of 1 over x plus x minus 1 dx. Okay, so let's start with the first one. Y equals 2x plus 1 over x plus 3. Like he said in that video, he's not saying these methods are the best method. Both, I love the method. Myself personally, I love it. And I know every other viewer will also love it. And that's why I can't keep it to myself than to show you guys. Now, we all know the traditional way in solving this kind of question. And that's quotient rule, isn't it? We are not going to use the traditional way in solving this. Let's see how we can go. I can take what the natural log of both sides, that is the ln of both sides, ln of y and ln of 2x plus 1, x plus 3. Now, why am I taking what ln of both sides? It's because it's very easy to solve what difference than you solving what quotient. Are we together now? So this is a rational function now. So in solving this rational function, it might be tedious a bit, and it's not that conducive. So, but if I change this to what difference, it becomes something simple, isn't it? Now, we all know that what the ln of a quotient is equals to what ln of what the difference. So this is going to be ln of y equal ln of 2x plus 1 minus ln of x plus 3. Are we together? Though this is supposed to be absolute value, but let's move on. Are we together now? If I take the derivative of this, that will be 1 over y, the y, the x, equal, if I take the derivative of what ln of x from composite function, that is function of a function, chain rule, you differentiate what you have inside there first, and if I differentiate what 2x plus 1, my result is going to be what 2. If I differentiate what ln of what 2x plus 1, that was going to give me what 2x plus 1. Why? Because if you differentiate ln of x, your result is 1 over x. Okay, so if that should be the case, minus ln of what? If I differentiate x plus 3, that will give me what? 1 divided by what? X plus 3. So what I need to do next now to arrive at my final answer is to multiply both sides by y. Therefore, the y dx equal y into 2 over 2x plus 1 minus 1 over x plus 3. So y is given to be 2x plus 1 over x plus 3. Therefore, the y dx equal 2x plus 1 divided by x plus 3 to multiply the whole function here. 2x plus 1 minus 1 over x plus 3, like this. So if I open these brackets now, my result is going to be that the y dx equal, this will cancel this, so I'll be having 2 divided by x plus 3 minus, if this should multiply this, we are going to have what? 2x minus 1 divided by x plus 3 all squared. So we can simplify further, right? So if we are simplifying further, we therefore have that dy dx equal, the LCM is going to be x plus 3 all squared. And this would be 2 into x plus 3 minus 2x plus 1. And this is our final result. I think it's awesome. Good. This is what you're going to have even if you apply what? Quotient rule. Now let's see if this method can work for another question. Yes. But I'll be using that other question to be a product rule. That is, you can also use this method in solving what? Product rule as well. Let's see. Okay, if I have that y equal x sine of x, and the question is to look for dy dx. Now, this is a product rule. Instead of product rule, I can also use what? ln. So, ln of y equal ln of x sine of what? X. You agree with me that ln of a product is equals to what? Sum of what? ln, isn't it? So this will be ln of y, ln of x, plus ln of sine x. Isn't it? Good. If I differentiate this, I will have what? 1 over y dy dx to equal 1 over x plus ln of sine x is the same thing as saying cos of x over sine x. So we therefore have that dy dx equal y into 1 over x plus cos x over sine x, like this. Thus dy dx equal y is given as x sine of x, then into 1 over x plus cos x over sine of x. Are we getting this now? Okay, so if I open this bracket with this, my result will therefore be dy dx equal, this x will cancel this, so I have sine of x plus sine of x will cancel this, so I have x cos of x. And this is just the same result you are going to have if you also use what? Product rule. Are we together? Good. So we can move to the next question now, and that's the integral of what? E to power of x sine of x dx. How are we going to solve this? I love this so much. You know, it's always difficult to solve two transcendental functions. When you say transcendental functions, we are talking about what? Non-algebraic what? Function. So if I'm to integrate two transcendental function, it's always difficult. And why? It's difficult because transcendental function will never reduce. So when you integrate transcendental function continuously, they will just keep on what? Oscillating. If I integrate what? Sine, I'll be having cos, then integrate again, half cos. So it's just continue what? Oscillating. It never reduces. So it's used to make it difficult. Now let's see how I'm going to integrate this. The question is integral of e to power of x sine of x with respect to x. Okay? Now, how I'll tell you something now. Instead of me to integrate this function like the method adopted by sybermath, instead of us to integrate, we differentiate instead. This is awesome. And this is one of the reasons why I so much love what is approach. And I can't keep it to myself than what showing you guys. Let's see, friends. Now I'm going to differentiate e to power of x sine of x instead of integrating it. Okay, so if I'm to integrate this, I will have what? E to power of x sine of x plus e to power of x cos of x using what? Product rule. Okay, let me call this equation star. If I call this equation star, I'm going to differentiate e to power of x cos of x also. So if I do this, my result will be e to power of x cos of x minus e to power of x sine of x. And this will be my what? Equation star star. Okay guys, this is awesome. Now, remember, if this is, we have to integrate towards e to power of x sine x. So let's try how we can eliminate what? E to power of x cos what? Cos x here. So that we can have what? We can have just e to power of x sine x. Are we together? Are we getting this approach? Good. If I decide to take the difference of equation 1 from what? Equation 2, or equation 2 from 1 rather. So I will be having d e to power of x sine of x dx minus d e to power of x cos of x dx to equal, this will give us what now? Okay, this will give us 2 e to power of x sine of x, like that. Okay, so if this should be the case now, remember, we are looking for what? We are looking for the integral of e to power of x sine x. So if that should be the case, we can therefore do something like this. If I take the integral of both sides, I will have integral of e to power of x, okay, integral of e to power of x sine of x minus cos of x d dx to equal the integral of 2 e to power of x sine of x dx. Okay, so if this should be the case, I can decide to divide both sides by 2. And if I divide both sides by 2, I will have that the integral of e to power of x sine of x dx equal 1 over 2 integral of e to power of x sine of x cos x d dx dx, because we are integrating with respect to x. This is negative, please don't forget. Are we together? Okay, so this and this would cancel. So if this and this cancel, then I have that. I think, pardon me to clean this. I will have integral of e to power of x sine of x dx to equal 1 over 2 as a constant integral of d e to power of x sine of x minus what? Minus the sine of x minus cos x. Okay? Are we getting this now? So let me quickly make a remark. If I have the integral of the x, my result is what? X, isn't it? So the same thing goes to this. The integral of e to power of x sine of x dx will therefore become 1 over 2 e to power of x sine x minus cos x. And this will be our result. Don't forget to put plus c. Do we see the way we integrate this now? Other than the traditional method where we are going to apply what? The integral by parts. So instead of solving this with integral by parts, we just adopt this method. And it's awesome. Thank you. Okay. So let's see another question that looks similar, like this. So instead of integrating e to power of x sine x, let's integrate e to power of x cos x. E to power of x cos x dx. How do we go about this? We do the same thing by differentiating this. So this is a product rule. We use the same thing. We have e to power of x cos of x negative e to power of x sine of x. So we again differentiate e to power of x sine x dx, and this will just give us e to power of x sine x plus e to power of x cos x. Okay, so we just add these two together. So when we have these two together, we have d e to power of x cos x dx plus d e to power of x sine x dx to equal, if I have these two together, this and this will cancel, then I have 2e to power of x cos of x. Okay, thus this one can be written just like we did before, e to power of x into cos of x plus sine of x. So d dx. So let me just put the d here. Okay, equal 2e to power of x cos of x. So guys, if I differentiate, if I divide both sides by 2, normal, I will have d 1 over 2 d dx 1 over 2 e to power of x cos of x plus sine of x, and this equal e to power of x cos of x. So let's take the integral of both sides with respect to x. So we therefore have that this and this would cancel. So I have the integral of e to power of x cosine of x dx equal 1 over 2 integral of d e to power of x cos of x plus sine of x. Okay, so normal, if I have integral of the x, my result is x. Thus, we have that the integral of e to power of x cos x dx equal 1 over 2 e to power of x cos x plus sine x. So, and this is our result. It's awesome. Thank you. Okay, let's go for the last one now, which is this. And it's also okay to look into that as well. Okay, so I'm going to be having the question of y 1 over x into x minus 1 dx. Oh, this would have been the toughest one if you don't understand this particular method I want to apply, because we are going to be looking at the sum of infinite series. Instead of looking at the sum of infinite series, we can just take this approach that I'm about to use. So this will just be integral of x minus x minus 1 divided by x into x minus 1 dx. Now, for you to see that the question still remains the same. If I expand these brackets with this negative, I will have x minus x plus 1, so which is still the same thing as the question. So let's separate this now. This way implies the integral of x into x, then x minus 1 dx minus the integral of x minus 1 over x into x minus 1 dx. So thus the integral of 1 over x into x minus 1 dx equal, now this will cancel this, therefore I will have integral of 1 over x minus 1 dx, the minus integral of this will cancel this, 1 over x dx. Are we together? Okay, so this is awesome. Now we can differentiate this we can integrate this very easy rather. So this is integral of the x over x into x minus 1. This will give us ln of x minus 1, then minus ln of x plus c. As simple as that. Okay, so let's look at a similar question to that. I believe you understand this now, so you can therefore apply this in your Cal 2 exams. Okay. Okay, so we have to look at integral of dx. Then we have e to the power of x plus 1. Okay, let me write it as 1 plus e to the power of x. Okay, guys, I think this question, I got this question from a friend 3 years ago. Although it was very difficult for me to solve it then, but I used the same approach that I used in solving the previous one. I used it then. And seeing sybermath using the same approach now confirm what the authenticity of that particular method. And it shows that thousands of mathematicians outside will have been using the same thing. So let's see how it goes. This is going to be integral of 1, then 1 plus e to the power of x dx. Let me write it like this so that I can see the clear picture. So if I want to integrate this now, if care is not taken, I'm going to find myself in doing what? Sum of infinite series again, which I would not like to do. So what I will do is just to do something similar like what I did in the previous example now. So I'll just say this is the same thing as integral of 1 plus e to the power of x, then minus e to the power of x, then 1 plus this dx. Do we get this now? You know, this and this will definitely cancel each other, so there's nothing changed there. So this will become integral of 1 plus e to the power of x, 1 plus e to the power of x dx, minus the integral of e to the power of x, 1 plus e to the power of x dx. And I think this is very easy now to approach. Therefore, this will give us 1, so this is integral of the x minus the integral of e to the power of x plus divided by 1 plus e to the power of x. Okay? I think this is quite awesome. And we are done with our result. The integral of this will give us what? X. The minus the integral of this is going to give us ln of e, so plus c. It's as simple as this. Okay guys, you don't understand how I got this result. Let me quickly show you. Let's say we have what? We're done with the class already. So let's say I have integral of e to the power of x, then 1 plus e to the power of x dx, and this is I'm going to let what? Let u equal e to the power of x plus 1, then the u is equal to e to the power of x dx, like this. Okay, so the x equal what? The u all over e to the power of x. Therefore, the integral becomes e to the power of x all over u. Instead of the x, I will have the u over e to the power of x. This and this cancel. Then I have integral of 1 over u du, and this is what? ln of u. And ln of u is the same thing as e to the power of x plus 1, then plus c. It's as simple as that. Okay, sorry. I'm not a teacher there. So, but you understand what I did there. Do have a nice day. Thank you.